So, hi everyone. First off, I'd like to have a show of hands. How many of you have heard about or used Tor? All right. How many of you run a relay? Yeah, not. So my talk is about the safety of the Tor network, and it's going to be 3 different topics. We're going to look at network diversity, we're going to look at the relay operators, and we're going to look at malicious relays. My name is Runa Sandvik. I work for the Tor project. The Tor project is a nonprofit. We have somewhere between 15 and 20 employees and contractors right now working full-time on Tor and other projects. And we have volunteers all over the world. We're also hiring, so if anyone's looking for a job, come see me after. The goal of Tor is to promote free speech, free expression, and privacy rights online. And we do that by developing Tor. We also do a lot of education and outreach. Over the past 2 years, we've done a lot of training for journalists. We've met with activists. We have done a lot of work with survivors of domestic abuse. And so we do a lot more than just developing this tiny piece of software. So, sort of like the background for my talk, over the past 2 years, I've had the opportunity to travel a lot. I met with a lot of interesting people. I've met with activists in Beirut. I met with journalists in Istanbul. I've met with university students in DC. And a lot of them have like the same sort of questions about Tor and the Tor network. You know, how safe is the Tor network? Who are the relay operators? What about malicious relays? How much network diversity is there? And what about the CIA, NSA, PRISM, and so on? So if we're going to just comment on one straight off, the CIA does not run Tor. Tor is not a CIA honeypot. Tor was originally developed by the US Naval Research Lab, but that was before 2000. Since 2002, Tor has been completely free and open source and developed by the Tor project. So before we start kind of go deeper into these topics, I'll kind of start with a quick introduction to onion routing. So there's 2 ways that you can run Tor. You can run Tor as a relay, or you can run Tor as a client. When you run Tor as a relay, you will set it up on a computer or a Raspberry Pi or whatever it is, your toilet. And you can decide to run it as an exit relay or a non-exit relay. So you can decide whether or not you want Tor users to exit onto the public internet from your computer. In the case that you're not running an exit, you'll be running what's called a non-exit, and that non-exit could also be what's called a guard relay, which is the first server that users connect to. So running Tor as a client, you download Tor onto your computer, you open it up, and your Tor client will then, first off, download the list. It's called a consensus. Download the list of all the relays in the network. And out of those roughly 4,000 relays right now, it will pick 3 guard relays. And for the next 2 to 3 months, it will only choose between those 3 when it chooses the first hop. So after choosing that guard relay, it will choose the middle relay and the exit relay. And after that, Tor will set up a connection between your computer and the guard relay and negotiate a short-term session key. It will then connect through the first server to the second server and negotiate a second short-term key, and it will do the same for the exit relay. So that when the whole circuit, which is the connection from you to the destination website, is set up, the data that you send, for example, I want to visit twitter.com, will be wrapped in three encrypted layers. So you send off the packet from your computer to the guard relay, and the guard relay will then peel off that 3rd outermost layer and see that, okay, the packet came from you and it's going to somewhere else in Tor. So it will send the data off, it will send this blob of data off to the second relay. Second relay will peel off that second layer, see that the packet came from somewhere in Tor, it's going to somewhere in Tor, but that's all it knows. So we'll send it off to the 3rd exit relay, or the 3rd relay, the exit relay, which will then peel off that final layer, see that it came from the middle relay, and see that it's going to twitter.com. So in this model, there is no single hop that will see what you are doing online. Now the challenge here is if someone, the same person owns the guard relay and the exit relay, that person can see what you are doing online. That person can see that you are using Tor to visit twitter.com. Another issue is the exit relay. The exit relay operator can look at any traffic going from her relay to the public internet. And I'll get back to that later on. So at the moment, there's roughly 4,000 relays in the Tor network, pushing around 2,500 megabytes a second in aggregate. And you would think that 4,000 relays, we have like 600,000 daily users. And you think that 4,000 relays is a good number. But if you look at this graph, it shows that out of those 4,000, only 1,000 of them are exit relays. And only 1,000 of them are guard relays. So when your Tor client is trying to choose which servers to send traffic through, it only has 1,000 or less options for the first hop and the third hop. So I figured a lot of you will probably want to know about how Prism or other spying programs affect Tor. And Tor was originally designed to protect government communications, to hide where you are and who you're talking to. So Tor can't hide the fact that you're talking, how much you're talking, or when you're talking. But Tor can give you location anonymity. If you're here at Defcon and you're using Tor to connect to Twitter, Twitter will see that you're the one logging on because you have a username and a password, but they won't know that you're here. So in the, like I mentioned, if the same person owns the guard relay and the exit relay, they can see what you are doing online. And recently, it's sort of, after Snowden leaked all of these documents, we learned that there are countries colluding, there are countries working together on other spying programs. So now the concern is not so much who's running the relays, but who owns the links, who controls the ASs, who controls the internet exchange points, right? It's not necessarily about the relays. So this kind of all fits into whether or not we should consider different threats, if we should reconsider the threat model for Tor. And so this is a paper that is, it will be published later this year, that a group at the US Naval Research Lab worked on. It's called Users Get Routed, Traffic Correlation on Tor by Realistic Adversaries. So they took Tor the way it works right now and looked at what happens if you're sending your data through relays that happen to be controlled by the same entity, by the same AS, or in similar internet exchange points, or by countries that are now known to work together on different spying programs. We are sort of considering how we can approach this. We're sort of trying to figure out if changing the way Tor selects relays is something that we should actually do, or if users are safer now than if we were to choose a different algorithm. So that is ongoing research right now, what is worth considering, I guess, when you're using Tor. So that sort of fits in with the topic of network diversity. You probably can't see that table, but so all this data is public, and this one is from Compass, COMPASS.torproject.org, and it shows the likelihood that you will have your guard relay, your middle relay, and your exit relay in different countries. So at the top of the list, there's a 25% chance that your first server will be in the US. There's a 23% chance your middle server will be in the US. And there's a 34% chance that you will exit in the US. And below that, there's a 29% chance that you will enter in Germany, that your middle relay will be in Germany, but only a 6% chance that you will actually exit in Germany. On the top of the list is US, Germany, Netherlands, France, Sweden. So we have 4,000 relays in like 150 different countries. But Tor will look at the relays that are offering the most bandwidth when choosing which relays to use for its path. It doesn't look at the countries. It looks at the bandwidth. And so the more bandwidth you offer, the more likely it is that users will actually pick your relay. But that means that we may not actually have as much diversity as we would like to, because all the relays are in countries like the US and Germany where bandwidth is free and where hosting providers are actually happy with us setting up relays. So I wanted to figure out, who the relay operators are. I wanted to see if I could answer the question of, has the NSA ever set up a Tor relay? So I looked at all the data, all the consensus documents that's been generated since 2007. It's all on metrics.torproject.org. And I tried to figure out, who owns the IP addresses. That was sort of my starting point. Who owns the IP addresses for all of these relays? And I did not find any government entities running relays. That means, well, one, they're not running any relays in their own data centers, but also that maybe they're not running relays at all. We now know about all of these spying programs. We know they have access to links to internet exchange points. They have connections all over the world. Why would they need to run relays? Right? They have access to all of this information in a number of other ways. They wouldn't necessarily have to run relays. A couple of sort of interesting observations or relays that did pop up was TBREG. If you used Tor back in like 2008 and you're on our mailing list, you will have seen this name pop up. So TBREG was the nickname of a few Tor relays that were running inside China. And were running as Tor exit relays inside China. And over the course of a year, TBREG had 20,000 different IP addresses associated with it. Now, I don't know who inside China would have access to, well, one, be able to set up a Tor exit relay, and two, have 20,000 different IP addresses in a year. But my guess is that, government, university maybe, but we don't know. We never actually caught this relay doing anything malicious. And after a year, it sort of just fell off the grid and we haven't seen it since. A couple of years later, Trotsky popped up. Was the name of a couple of thousand relays in Eastern Europe, all running on sort of dial-up, or at least offering very, very, very little bandwidth to Tor. So it wasn't an exit, there was no contact information given as to who were the relay operators. And at that point, we decided to take it out of the consensus because we believed it might be a botnet. We haven't really been able to figure out whether or not it was a botnet, but we only saw Trotsky for 2-3 weeks, and that was it. So when I said take out of the consensus, we have a way, and I'll get back to that later, we have a way to, when we see that there are relays misbehaving, we have a way to mark them as bad, and then take them out of the consensus. It means that when client downloads the list of the Tor relays, it will just not choose bad exits for its circuit. So Orbot Orbot is the Tor for Android. So you can run Tor as a client on your phone or your tablet, and you can browse through Tor. You can also run Tor as a relay on your phone or set up a Tor hidden service. And I saw a number of nicknames, a number of relays with the Orbot nickname popping up in the Middle East. There are a lot of users with mobile phones, with smartphones, and apparently a lot of them set up relays a couple of years ago as well. So there are a lot of different groups sort of running relays. There are those who run relays on a Raspberry Pi. There are those who sort of try and run bigger groups of relays. In the case of Orbot or Trotsky or TBREG, they may or may not actually be malicious. Then there's the groups that are sort of supporting the Tor network in a completely different way, and in a very, very good way. So who's heard of torservers.net? Some. Okay, so torservice.net is a German nonprofit whose only goal is to increase network diversity. They will take donations and spend that money on relays for the Tor network, primarily Tor exit relays, which is when you saw the list of, there's a 23% chance that you'll exit in the US or in the Netherlands. Most of those relays actually belong to torservers.net. So when you're using Tor, you are more likely to end up using a relay owned by torservers.net or one of the other groups that I'll show, because they're running so many relays and because they're offering so much bandwidth. So you're more likely to use relays that are run by people that we trust rather than some random guy in, I don't know, the UK, for example. The Chaos Computer Club is sort of similar. They also run relays offering a lot of bandwidth. I think in the list of, if you create a list looking at which relays offer the most bandwidth, Chaos Computer Club would come up as number 2. So another group is BFRI in Sweden. They just set up, I don't think they have nonprofit status yet, but they've just sort of managed to get everything together, and they're able to accept donations and spend, just put the money towards actually running high bandwidth relays. Another group is Noise Tor out of San Francisco. They will also take donations. Some of these groups, I'm not sure about all of them, but they will also take donations in Bitcoin. So if you can't run a relay, then maybe you can just donate to someone who can actually set it up for you. So malicious relays. There are, I guess, 3 groups of malicious relays. The first one is malicious but not intentional, meaning that someone set up an exit relay and they have, they have OpenDNS or they have an antivirus that is blocking certain sites. And while they may feel safe using that, having that on a Tor exit relay means that Tor users will also sort of end up with the same filter. So if they can't visit google.com, then any Tor user will be unable to visit google.com. In those cases, we try to contact the relay operators. And when you're setting up a Tor relay, you can sort of put in your contact information if you want, and if something is actually wrong, or we're asking you to upgrade your relay or something like that, we know how to contact you. So we will try to contact these relay operators and sort of ask what's going on and see if maybe they can just reconfigure their computer to not censor users. The second category is straight up malicious. Those that try and strip off SSL or do some other sort of man in the middling, or again censor sites just more actively. We will try to contact the operators when we can, when there is contact information given. But if they're found to actually be just malicious and they don't have contact information, we'll just take them out of the list. The third category is passive, sort of more malicious, but not necessarily detectable, in the sense that they will be logging traffic. So I mentioned that when you're using Tor, the traffic from you to the exit relay is visible to the exit relay operator. It means that the exit relay operator can see what people are doing online. They won't know necessarily who's doing what, but they'll see what people are doing, which websites people are visiting. And in some cases, people set up exit relays just to log all of this information. That is not something that we can actually detect, and that is a risk. Just a risk to be aware of, but I would say that it's probably safer to use Tor than not these days. So a question I often get is, how bad can it get? Say that you're using Tor, you happen to head up on a malicious exit relay, how bad can it get? My answer is that it depends. I know that's usually an answer that you'd hear from a lawyer, but it really does depend on what you're doing and for how long you're doing it and whether or not you're actually logging on. Say, you're using Tor to access Twitter. You go to twitter.com and your browser gives you a warning about a fake SSL certificate. Now, if you choose to accept that certificate and log on, you're giving the adversary, the attacker, your username and your password, and you have lost. And that is true regardless of if you're using Tor or not. In the other case, if the person is just logging traffic and you're not logging in anywhere and you're not communicating any sensitive information, then that person will just get lots of random data, lots of websites that you're visiting, but not necessarily a way to tie that back to you. Another thing to note is Tor, when creating those circuits, when choosing those 3 relays and using them to visit all of the websites that you're visiting, Tor will choose a new path for your traffic every 10 minutes. So if you're visiting Twitter and you spend, 20 minutes on Twitter and then you open a new tab in your browser, Tor will create a new circuit for you. Whenever Twitter has to open a new TCP connection to pull in new content, Tor will open a new connection for you. So I'm not sure how to best answer this question of how bad can it get, because it really does depend on what you're doing. But I think in a lot of cases, it's probably better to use Tor than to not to use Tor. And the threats that you see on Tor are pretty similar to this, using the open wireless network at Starbucks or elsewhere. So we have a couple of different tools for sort of finding these malicious relays. The first one is called the consensus tracker, which we created somewhere between the time we saw TBREG pop up in the consensus and Trotsky. So consensus tracker is essentially just a script that every hour it will look at the list of relays and figure out which relays are new, which relays just joined the network. And it will just send us an email. And anyone can subscribe to the list and see the list of new relays joining the network. So the information we get is sort of the IP address, the port, which ports if it's an exit relay, which ports it allow exit to, content information if that has been set, just sort of basic info. It doesn't really check for maliciousness, but if we suddenly have 1,000 relays pop up in Syria, it's at least something that we can monitor and keep an eye on. So a couple of years ago, we created Snakes on a Tor, or SOAT, as a Google Summer Code project. The goal of SOAT was to have a set of tests that would allow you to check for fake SSL certificates, so any sort of tampering with DNS, any other types of censorship, and it sort of worked for a while. It was written in Python 2.5, and it is no longer maintained. So for the past probably 2-3 years, we've been working on another project called UNI, the Open Observatory for Network Interference, which if you run what's called UNI Pro, the client, it will check for censorship, essentially. And hopefully, in 6 months or so, UNI Pro will be able to do what SOAT once did, so that we can more actively check for malicious relays or misbehaving relays. So the tool we have right now is the Tor Exit SSL Checker, and it is one thing. It checks for fake SSL certificates. It will take the list of exit relays and a list of URLs that you have given it, say Twitter and gmail.com, and it will connect to the exit relays and download the SSL certificate, and then it will do the same over non-Tor and compare the two. And if there is a difference, it will give you a warning. So yeah, we only check for SSL certificates right now. We hope to be able to check for other types of malicious behavior in the future. So there's three topics that I sort of wanted to touch on that I hope that you will leave this talk with. One, I want you to use Tor. It seemed like a lot of people were already using Tor. In the case that you're not, please do. We always say that anonymity loves company. So the more people that use Tor, the better off you are. If you're the only person at Defcon using Tor, you sort of stand out. If you're one out of 12,000 people here using Tor, you're better off. So the more people use Tor, the better. Two, run or fund a fast relay. Not a lot of people here run relays. I'm not sure why, if it's lack of bandwidth, if you just don't know how, if you're worried that you'll be an exit relay. But no matter what the reason is, you can always fund a fast relay. Funding torservers.net.
We're back.
You're back?
We are. I think you know the routine. Everyone else in the audience, what are we going to do now? That mic is dead, Paul.
Packed house, packed house.
I have the mic, actually.
That mic is, just yell.
Well, can I just get really close then?
No.
Okay.
Just talk really loud. That was a good answer.
Okay, you all know the routine. What are we going to do?
You need someone from the audience.
Oh, yeah. Do we have any first-time attendees?
Awesome.
You,
Your
sir.
fiance is here?
Come
I
up.
put him all the way in the back.
Oh, did you? You
Yeah.
don't want him to come up?
No.
Oh, okay.
Okay.
Can I say that?
Sure, you can say that. Thanks.
All right. To our first-time speaker and our first-time attendee.
I got a lot of time for questions.
We're suddenly like the Keystone Cops.
I sort of wish I had started with that. You can run or fund a fast relay and help increase network diversity, or you can run an exit scanner or help us improve the ones that we already have and help us find misbehaving relays. So at this point, being first-time speaker at Defcon and sort of talking a lot faster than I usually do, I have a lot of time for questions. So if you have questions, you can line up with the microphone up front.
Is it safe legally to run an exit node if the people on the network are doing illegal things?
I got half of that. Do you want to try and repeat it?
Is it safe legally to run an exit node if the people exiting the network are doing illegal things?
Okay. Is it safe legally to run an exit relay if the people using your exit relay are doing illegal things? Running an exit relay is, in some cases, it can be a bit risky. So it means that any Tor user, 600,000 users, a lot of them will be using your server to access the public internet. So it means that anything that they do online will be seen as coming from your computer, from your IP address. Over the past years, there's been stories about people in Germany having their doors knocked down and their computers taken, or a series of DMCA takedown notices and similar. We have spent a lot of time trying to educate law enforcement, teach them what Tor is, how it works, when or how they would encounter Tor when investigating people. And that's worked out pretty well. We have sort of helped them understand that when they do hit an exit relay, it is Tor. It doesn't actually log any information. There is no information to be found there about the Tor users. But at the same time, if you feel that that is a risk, then running a non-exit is probably the safer option. So we have a blog post called Tips for Running an Exit Relay with Minimum Amount of Harassment, which sort of just lines out a series of steps and things to consider if you want to set up an exit relay. Sort of, run it on a dedicated server. Don't have your personal photos and GPG key and whatever else, chat logs, on the same server that you're running a Tor exit relay. Do not encrypt that drive in the server that is running the Tor exit relay. If you have a server with a non-encrypted disk running only Tor as an exit relay, and Tor is not logging anything, there will be no information on that server for law enforcement to dig through. So I would say if you're considering setting up an exit relay, that would probably be the first sort of page I would send you to read up on. Whether or not it's safe legally, I'm not a lawyer, so I can't really answer that question. Sorry? Exonerate Tor, yes. That is a list of, it's a service that allows you to enter an IP address and see if server X was running as a Tor exit relay at time Y. So in the case that you do run into issues with law enforcement, you can use that service to sort of point them to our page and sort of explain to them that you were actually running an exit relay. If you do run an exit relay and you run into problems, you can also email us and we will send a signed letter just confirming that yes, you were running an exit relay at that point in time.
So there's hidden entrance nodes via bridges. Has there been any look or work into having hidden exit nodes in a similar way?
So having hidden exit nodes?
Yeah.
So question is about bridges. The image that I showed of how Tor works that mentioned the guard relay, we also have something called bridges, which is similar to the guards, just that they're not listed on the internet. You can't find a list of every single bridge, which means that if you're in China and you need to connect to Tor and Tor is being blocked, then you can use a bridge instead. I'm not sure if we have even considered hiding the exit nodes. I'm not sure if that would actually be a good defense. It sort of seems to me like it would be just a bit of an arms race. We would hide them, someone would find them, and it would continue from there.
Sure. What about running relays in the cloud, and how, or like for instance, if there are just a whole bunch of cloud-based, like Amazon AWS-based relays, what does that do to your network diversity?
Okay. Relays. So with Amazon specifically, you are allowed to run a bridge. Running a relay is also allowed as per their terms of service, but you will be paying too much money for bandwidth. You just don't want to do that. And an exit relay is not allowed in their terms of service. But if someone were to suddenly set up thousands of relays to join the network, I'm not sure it would help the diversity too much. So Tor will only pick fast relays to use for its circuits. So if you have like 1,000 sort of slow relays joining the network, then we would have 1,000 sort of slow relays joining the network. I don't think it would do much to users.
My question's pretty specific regarding, are you aware of whether or not Google Fiber's terms of service restrict you from running an exit relay or not?
Sorry, if?
Google Fiber's terms of service, would that restrict you from running an exit relay or not?
I don't know. If anyone from Google is here who can answer that question, then we would all like to know.
No servers on Google Fiber. They probably say no.
No servers at all? If anyone from Google is here, then I'd like to talk to you.
No computers on Google Fiber.
Any other questions at this point? I didn't hear the full. If there are more malicious relays than none? Okay, if there are more bad users than good users. Okay. We don't know. I mean, so you go to our website and you download Tor, and the only thing that pops up in our Apache logs is that someone visited Tor. We don't log your IP address. We know that people are downloading Tor, but that is it. We have no information. We don't know what you're using Tor for. Back in the day, someone did a study to see at least which protocols were used the most, and it was just mostly web traffic. But apart from that, we have no way of telling what people are doing over Tor. We were accidentally banned by Facebook, yes. The issue that was a month ago, okay, so it does happen. So someone used Tor to sort of try and scrape content from publicly available content from Facebook, and Facebook sort of accidentally blocked a ton of Tor exit relays. So it does happen, but like we have no way of telling how often it happens or how many users are actually misbehaving that way.
Can you speak to Onion services?
What about hidden services?
Can you briefly detail what they are?
Okay. Tor hidden services, dubbed by the media as like dark web, deep web, is a way of hosting content anonymously over Tor. So it means that you can set up a website and it will have the URL of like 16, like a random string of like 16 characters and .onion at the end. And it will only be accessible over Tor, and no one will know that you are the one hosting the site. And you will not know who's visiting the site because everything is over Tor. The content cannot be censored. We cannot find out who's actually running Tor hidden services. And so it's sort of just anonymous hosting in a way. Recently there was a paper published pointing out a number of issues with Tor hidden services, and we wrote a very long blog post explaining all the things that we would like to see improved with Tor hidden services.
How do you establish trust for the consensus?
So when you set up, the question was, how do you establish trust for the consensus? How do you make sure that the list clients download is a safe list? When you set up a relay, your relay will tell 9 directory authorities that it exists. And these 9 directory authorities will then confirm that your relay has the IP address that you've said that it has, that the nickname matches. If it's an exit, it will make sure that you can actually exit. And then these 9 directory authorities will vote on this information, whether or not that information is correct. If the majority of them vote that, yeah, it's correct, it's valid, then that relay makes it into the consensus. And once they have done that for all the relays in the network, that list is then signed by every single directory authority. And when the client downloads this list, it will check that the signatures are okay.
I had a follow-up question to that. Who controls the directory authorities, and who controls the Onion domain name services or servers?
Okay. The directory authorities are run by core Tor project developers or people that we trust. So there's a good mix of some of them are in the US, some of them are outside of the US, some are run by Tor people and some are not. But you have to be a trusted member of the community to be able to run one. The second question was about the .onion domains. No one really controls that. You generate a domain when you set up a Tor hidden service. And that's that.
Talk about Japan.
Japan?
Is there sufficient diversity in the directory authorities to protect court orders in a single country?
is there diversity in the directory authorities to protect from court orders for a specific country?
If the NSA decided to spin up 1,000 relays, and then it served you guys with some kind of national security bubble that forces you to mark all the other things as bad, is there sufficient diversity for any
If the NSA served us with any type of letter to mark relays as bad and to effectively redirect all Tor traffic to the NSA, then we just wouldn't do it. Is there any way for an exit relay to figure out who the Tor user is? No. So the only information that the exit relay has is that people are doing stuff, that people are watching, videos of cats. So the only thing that you can do if you were to attack Tor users would be to make sure that you are that first hop, that you are the guard relay and that you are the exit relay. And doing that when targeting a person seems really, really difficult. I mean, I'm sure you have, or at least the NSA maybe probably has way better options to actually target people than to try and spin up 1,000 Tor relays. What? So Tor is TCP only right now. We have a proposal for UDP, but I'm not sure what the status is. I don't think we've done a lot of work on that for a while. We have done more work on getting Tor to play nice with IPv6.
How about hardware integration?
Sorry, hardware. Can you repeat that?
Hardware integration.
Hardware integration, okay, thanks. So we have a project called the Tor router, which the goal is to just take like a stock router and put Tor on it and make sure that, it sets up a wireless network where everything that you do on that wireless network is sent through Tor, and that it is also running as a bridge or a relay, or an exit relay, for example. That project will probably be announced in about 6 months. There are other projects like the Onion Pie. I know Freedom Box has sort of worked on some stuff. There's a lot of work being done. We need more people to sort of help us test those projects, but we don't have anything right now.
What's your opinion on an exit node filtering traffic?
If you're running an exit node to filter traffic, then you just might as not just don't run an exit node at all. Like
sites like child pornography, for instance.
Sure, okay. If you want to talk about child pornography specifically. Running an exit relay to filter content in general means that, who are you to decide what people can and cannot watch online, right? So you obviously, I think we all agree child porn is bad. But what if we gave people the ability to actually decide what Tor users can and cannot visit through their exit nodes? And I decided watching videos of cats is bad. So suddenly I am censoring a number of Tor users who wanted to look at totally legitimate things. So we just decided that we shouldn't decide what users can and cannot watch. It also means that we cannot be asked or forced by anyone to censor anything or give out any type of information. We don't have anything. We don't control the network. Users do. Anything else?
So just one, to that last point, is there a problem right now with a deficiency in the number of exit nodes? Like if I can run an exit node by filtering certain sites like child pornography sites that are illegal where I am, if my jurisdiction and prevent me from running a node, do you think it's worth running an exit node under that situation? Are you guys desperate for exit nodes?
We are desperate for exit nodes, but we would prefer exit nodes that are not touching user traffic regardless of what it is.
Will ISP know anything about the sites you are visiting or any logs you get?
There are absolutely no logs.
For the client and ISP?
None. So the question was if we have any logs at all. And the answer is no, we don't have anything. When you visit our website to download Tor, we write just zeros in the log. Or we write all zeros if you're visiting the HTTP version of the site and a 1 at the end if you're visiting the HTTPS version. So you download Tor and we don't know that you downloaded Tor. You start up Tor and there's sort of two entities that will know that you're using Tor. It's your ISP and it's the guard relay. They will know that you're using Tor. They won't know what you're using Tor for. And the exit relay will know that someone is using Tor to do something, but they won't know who. So there are no logs. There's nothing to be subpoenaed. We cannot be given any magical letters to force us to do anything. We don't have any info about our users.
What about your ISP?
It's a good point. The ISP, yeah, the ISP, whoever the backbone provider is. It's a good question. The question is, if they actually look at that traffic. Do you know? Is that like a common thing for ISPs or service providers on a top level? Does a backbone provider log incoming connections to websites that are hosted by people? Sorry, if we're going to put together a list of Tor projects, is that the question? Tor apps? So we have a list on our website talking about products and services that we have. And if you're not in that list, then it is not a project that is maintained or developed by the Tor project.
Have you ever seen Tor exit nodes attacking browsers?
No, I have not seen any Tor exit nodes attacking browsers.
So for users running like the Tor browser bundle, what safeguards are in place to prevent the exit relay from serving up like a malicious twitter.com and sending some sort of malicious program back to their computer to kind of make a connection on the open web?
So if there are any restrictions on?
Well, like what kind of protections are there?
So the Tor browser bundle blocks a lot of things by default, like Flash and Java and some JavaScript and things like that. But that is it. If an exit relay is actually able to inject a very specific type of exploit into the user's traffic, then there are no, if you can do that without Flash or Java or getting the user to open an attachment, then yeah, okay, you win. Okay, so he's waving at me saying that I'm out of time. So I figured we can meet in the chill out room if you have more questions and we can kind of continue there. Thanks.